to my channel. Today we are going to do a very important topic based on standard 12 and of chapter electrochemistry. So today we are going to do the products obtained at the electrodes of during the various electrolysis of the salt. So today's class is important for your boards and as well as for your competition, because from this topic many questions related have been asked. Okay, so you can write down the topic: products obtained at electrodes during electrolysis of electrolytes, various electrolytes. Clear? So what we will do in this topic, we will take various electrolyte. First we will take in the molten state, then we will take their aqueous solution and then we will do the electrolysis. So first we will understand what is the meaning of electrolysis. So electrolysis is a process. In my previous video, in the first lecture itself, I have explained electrolysis. Electrolysis is a process in which electric current is supplied in a cell where the products are obtained, where the product gets separated at the different electrodes. Clear? So see here, what I will do, first I will take an example of molten NaCl. I will take one beaker, clear, and here I will put two electrodes, and here I will fill molten NaCl. In this beaker I will fill molten NaCl, clear, and I will connect through a battery. So you know this is a positive charge and this is a negative charge. Okay, so this is a positive charge, this is a negative charge. So from the negative charge there will be a movement of electron, so electron will come here, means this is known as an cathode. Similarly that will be an anode. Clear? So from the portion where, from the battery where the electron is coming, so you know electron will always come from negative parts or negative terminal of the battery. So this portion from negative terminal of the battery or the electrode which is connected to the negative terminal is known as a cathode, and opposite it is known as an anode. Here you know molten NaCl means Na plus and Cl minus. So first point, in molten state of salt, ions are present. Ions are present means, see here in this beaker I have filled what? I have filled molten NaCl. Means here molten NaCl ions will be roaming, Na plus and Cl minus. There will be a random motion in the solution here, Na plus and Cl minus. So what happened? As I pass electric current, or as I pass the electric current, or as I connect to the battery, these ions moves. These ions move, the random motion stops. See, before passing the electron, this beaker containing NaCl, in NaCl the ions are there, Na plus and Cl minus, means Na plus and Cl minus particle are there, and this particle randomly moving here and there. Okay, they are moving here and there, but as and when I start to pass the current, as I pass the electric current, the random motion stops. The random motion stop and the ions starts to move their respective electrodes. Okay, so what happened now? See here, so this negative terminal of the battery, so this can be, I can call as a negative charge, and this will be the positive charge. So as I pass the electric current, the ion starts to move their respective electrode, that is the ions move towards their opposite charge. Clear? Means, see here electrons are coming, so here the cathode is considered to be negative and here anode is considered to be positive. So as and when I pass the electric current, this ion starts to move. Where this ion will move? Their opposite charge. Now here Na plus will starts to move towards negative side and Cl minus will starts to move towards anode. So here Na plus starts to move toward cathode and Cl minus starts to move towards anode. Okay, so as I know, as Na plus starts to move towards cathode, and at cathode what occurs? Reduction. So Na plus, so at cathode reduction occurs, that is Na plus plus electron gives what? Na solid. And at anode, who will move? At anode, Cl minus will move. Yes or no? See here Na plus starts to move towards cathode. Why? Because here cathode is negative charge. You can see here. And why cathode is a negative charge? Because electrons are coming here. Yes or no? Where the electrons will be there will be negative charge. So opposite charge will be positive. So here Na plus starts to move towards cathode because Na is having which charge? Plus charge. So always as I pass the electric current, the ion starts to move towards the respective electrode, or ions move towards the opposite charge. Means if ion is positive, it will move towards the negative electrode, and if ion is negative, it will move towards the positive electrode. So here Na plus will move towards cathode and Cl minus will move towards anode. So at cathode what I will get? I will get Na at cathode reduction occur. That is Na plus plus electron gives what? Na solid, and anode oxidation occurs. At anode oxidation, and you know in oxidation means loss of electron. So here 288. If you see Cl minus, chlorine atomic number is 17. That is 287. Now here I have Cl minus, that is 288. Now there will be loss of one electron. So here the electronic configuration will come is 287 because one electron is moved, and 287 is an electronic configuration of what? Single chlorine. But chlorine does not exist as a Cl, it exists as a what? Cl2. So here 2, here 2. Clear? So what products I obtain? At cathode I will obtain sodium, and at anode I will obtain a chlorine gas. Clear this part? So at net reaction, if I write down here, if I write down the net reaction here, what I will get? See here, if I multiply this 2 electron here, this 2, redox reaction, 2 electron gets cut, and the answer will be 2 Na plus 2 Cl minus gives what? 2 Na plus Cl2. Clear? So this product will be obtaining at cathode, and this product will be obtaining at anode. See, this theory no one will ask. They will ask in the MCQ that if I do the electrolysis of an NaCl, which NaCl? Molten NaCl, what products are there will be obtaining at anode and cathode. So for molten NaCl, at anode, what you will obtain? At anode, chlorine gas will be there, and at cathode, sodium will be there. Clear this part? So this is the portion, or this is the electrolysis of an NaCl. Clear? Now see here, this process what we are doing. No? See, we have obtained the free metal, that is we obtain the metal and the gas at anode and cathode from the salt. So this process is known as an electrolysis process. And in an apparatus where electrolysis occur, this is an apparatus, yes or no? Or the device or the apparatus where electrolysis occur is known as an electrolytic cell. Clear this part? So this is a device where the electrolysis occur is known as an electrolytic cell, and this process of separation of ions and converting into the respective free metal is known as free state is known as a what? Electrolytic process or electrolysis. Clear this part? Now see here. So I hope you have taken the screenshot. Now I will not draw this whole diagram, directly we will do it. Okay. So this was the first question, that what products can be obtained when the electrolysis of molten NaCl is done. So you understood, at anode we will get chlorine gas, and at cathode we will get sodium. Clear? Now see here. So we will go with the next topic. or before that I will give you one key point. What is the key point? Check it out. One shortcut I will give you. So you remember one shortcut, because now we will start to check according to the, or before going to this key point, we will do certain one more question. So see here, second I will go for molten. I will go for molten or fused. Both name are same, okay? Fused NaBr. Clear? So see here, now how to do this? So question remains same. What are the product obtained at the electrode during electrolysis of NaBr? Now see here, NaBr. So we will split this, Na plus and Br minus. Clear? Now this is a positive ion. Yes or no? As I have shown just now in the theory, that ions will move towards their opposite charge electrode. So this positive will move towards the negative electrode, that is what? Cathode. So this Na plus will go towards cathode and this Br minus will go towards anode. Yes or no? At cathode what occurs? Reduction. At anode what occurs? Oxidation. Please remember, cathode reduction, anode oxidation. Clear? Cathode reduction, anode oxidation. Clear? So here at cathode, who will go towards at cathode? Na plus will go towards cathode. Okay, and at cathode what occurs? Reduction. Reduction means what? Gain of electron. So here Na solid. Similarly at anode who will go? Br minus. And at anode what occurs? At anode oxidation occurs, and oxidation means loss of electron. So this Br minus, see this minus means gaining of electron. So this gained electron I have removed. So what it will form? It will form Br. But you know, fluorine, chlorine, bromine, iodine, they are diatomic molecules. So they will form as Br2, and all are gases there except iodine. Okay, so this Br2 is a gas. So here what I will obtain? 2. Here I will obtain 2 electron. So balance the reaction. 2. So what I will get? This 2 electron gets cut. So 2 Na plus 2 Br minus will form what? 2 Na solid plus Br2. Clear? So what product we obtained? So at cathode sodium is obtained. You can see here. Yes or no? This Na plus and Br minus have been converted into product what? Na and Br2. This Na we obtained at what? Cathode, and at anode Br2 gas is obtained. Please remember this. So at cathode we will obtain sodium, and in anode we will obtain as bromine gas. So these are the product obtained at cathode and at anode during the electrolysis of molten or fused NaBr. Please write it down. Okay. Next we will take PbBr2. PbBr2. Clear? So here during PbBr2 what will happen? So we will see this. PbBr2. So again you split it, that is Pb plus 2 and Br minus. So this is positive, will move towards negative electrode, that is at cathode, and Br minus will move towards anode. Clear? So first we will see at cathode. At cathode what occurs? At cathode occurs what? Reduction. Please remember, cathode, reduction, anode, oxidation. Then one more shortcut I will give you, we will see later on, but just now you remember, at cathode, reduction, anode, oxidation. So at cathode who is there? Pb plus 2. It will undergo what? Reduction. Reduction means what? Gaining of electron. So how much you can gain the electron? 2 electron. Because here plus 2, so 2 electron will be gained. If it was here plus 3, so I would have written 3 electron. If it would have here plus, so I would have written 1 electron. Here plus 2 means 2 electron. So it will convert into what? Pb solid. Clear? At anode, Br minus will go. See here. And at anode what occurs? Oxidation. Yes or no? Oxidation means what? Loss of electron. So electron will be lost. So So see here, this Br minus have gained one electron. The gained electron is lost. So it will convert into what? Br. But I told you, fluorine, chlorine, bromine, iodine, they are diatomic molecules. So it will form Br2. Clear? Now balance the reaction. 2 Br minus, here 2. Clear? See, electron is balanced. 2 electron get cut. So Pb plus 2, 2 Br minus will form what? Pb plus Br2. This Pb is formed at where? Cathode. And bromine is obtained at where? Anode. So what are the product? So at cathode, during the electrolysis of PbBr2, at cathode lead is obtained. Clear? And at anode, Br2 is obtained. In this way, we can go for molten PbCl2, many we can do. You feel it very easy. Directly you can determine, or in shortcut only you can say, here at cathode Pb will be obtained, and at anode bromine gas will be obtained. So this it looks very easy, but this case will not be same with aqueous solution. Here, see, here we have done the 3 example. In 3 of the example, I have taken the molten or fused. I have not taken the aqueous. The problem come when aqueous will come. During the aqueous solution of certain salt solution, we have to think who will come at anode, who will come at cathode. So this is today's main topic. This was just a very small topic, and it's very easy topic also. That directly for any molten or fuse, you can directly determine the positive part will go towards cathode and negative parts will go towards anode. There you can do oxidation reduction, not an issue. But when this salt, if they are in aqueous state, they are aqueous state. So aqueous state means what? The salt are dissolved in water. So at that point, who will come at anode and who will come at cathode? That is the main topic which we are going to discuss now. So you can write down this. Please take a screenshot, then we'll go further. I hope you have taken the screenshot. Now you write down. Before going to this, you write down one shortcut. See here, we'll understand one shortcut. If you remember this shortcut, see, now I am going to do the products obtained at the electrode of during electrolysis of aqueous solutions. Here I have taken just molten solution. See, you can see here, in first I have taken molten NaCl, second I have taken that NaBr, third I have taken PbBr2. This all 3 things I have taken molten. I have not taken aqueous solution. Now we are going to do electrolysis of an aqueous solution of the certain salt, and we will see the products obtained at cathode and anode. This is bit difficult. You have to remember certain things. Before going to this portion, I will do certain key points, certain shortcut. You have to remember. If you remember that, if you mug it up there, it will be very easy to obtain the products. Now see here. See, first shortcut, remember at anode, remember shortcut, I am writing the shortcut, okay, shortcuts or key point, you can write down anything. At anode, oxidation occurs, yes or no? Oxidation means loss of electron, and gas is liberated except hydrogen. Hydrogen will obtain at cathode, okay. So this is the shortcut. At anode, oxidation occurs. Oxidation means loss of electron, and at anode gas is liberated except hydrogen. Hydrogen is obtained at cathode. Please remember this. At anode what occurs? Oxidation. Oxidation means loss of electron, and at anode gas is liberated. At anode gas is liberated except hydrogen. So why hydrogen? Hydrogen will be liberated at cathode because positive charge, H plus. Clear? So please this remember first shortcut, that anode oxidation occurs. Oxidation means loss of electron, gas is liberated except hydrogen. At cathode what occurs? Reduction. Yes sir? Okay. And here gain of electron. See here, gas is liberated at anode, and at cathode metal is deposited. Metal is deposited. And if there is an hydrogen, hydrogen is also liberated. Hydrogen liberated. These are the shortcut to be remembered. If you remember this, your topic will be very easy, else you will get confusion. More confusion will be created here. Okay. So these are the shortcuts. What is the shortcut? At anode what occurs? Oxidation. Oxidation means loss of electron, and at anode gas is liberated. At anode gas is liberated. Then at cathode reduction occurs. Reduction means gain of electron, and gain of electron means metal is deposited, that is, and also hydrogen is liberated. This was the first key point. Second key point, see here. Remember, mug it up, oxidation reaction and reduction reaction of water. So see here, H2O. Last class also I explained you, okay. So at H2O at anode means I am writing oxidation reaction of water. 1 minute. Feeling difficulty? See, there are certain key points you have to remember. If you remember certain key points, further topics will be very easy, okay. And there are certain things which to be mug up. You have to mug it up, okay. See, we have to focus on the knowledge also, and we have to also focus to take the marks. So directly everything you cannot understand, okay. So certain things to be remembered, so that only you can understand further things. So these things are to be remembered. Write down 2-3 times, remember it, speak 1-2-3 times, write it down, you will get the practice. Once if you get practice, you can find any answer. And this topic is really very important, so please be focused here. Clear? So now, another key point you should remember, that is oxidation reaction of water and reduction reaction of water. So see here, H2O, I am writing the oxidation reaction, so electron will be lost. So I am writing the oxidation reaction of water, that is electron will be lost, and electron is lost means at anode. Yes or no? So this oxidation occurs at what? At anode. So this is the anodic reaction of water. So O2 will be liberated. Remember one thing, whenever water undergo oxidation, oxygen gas is liberated and H plus is occurred. What occurs? H plus. See, balance the reaction. Balance the reaction, when I do the balance the reaction, that is 2 here, that is 4, and here 4. Means 4 Faradays are required during the oxidation reaction of water. Please remember. So this is the anodic reaction of water, or you can write down oxidation reaction. Yes or no? Because at anode what occurs? Oxidation. So at anode, oxygen is liberated. During the oxidation reaction of water, 4 electrons are lost, or 4 Faradays are lost, and byproduct is H plus. Clear? Now at cathode. At cathode, what will happen to water? First, at cathode, electron will be gained. Yes or no? Water will gain the electron, because at cathode there is a gaining of electron. Okay. Now, when it gains the electron, here hydrogen is obtained. See, here at anode oxygen is liberated, at cathode hydrogen is liberated, plus OH minus will be liberated here. Please remember this. Here what will liberate? OH minus. Now balance the reaction. So 2 and 2. Clear? So here 4 electron. So this is the anodic reaction of water, and this is the cathodic reaction of water. See, at anode, during the oxidation of water, oxygen is liberated in this way, and there will be 4 Faraday, and byproduct will be H plus. During the cathode, 2 to 4. Sorry. 1 minute. I will write down today 4 H plus is 4 electron, 2 H2O2. Sorry, here 2 electrons. Sorry, 2 electrons. Okay, so 2 2s are 4, so you have 4 and 2. I hope you understood. Okay, so please see here, at anode, water will lost 4 electron, oxygen is liberated, and H plus is liberated. At cathode, water will gain 2 electron, and hydrogen gas is liberated, and OH minus is liberated. Byproduct here OH minus, here H plus. And at anode, oxygen, and here hydrogen. Here one thing more you remember, you should mug up here. Okay, so you have to mug up the SRP value of these two reactions. So write down the SRP. SRP value means standard reduction potential, and remember SRP value of water. We write down the SRP reaction of water at cathode. You write down minus 0.83 volt. SRP value of water, that is minus 0.83 volt, and for anode SRP value write down 1.23 volt. Please remember this. You have to mug it up. Okay. So SRP value you should mug it up. So this is at anode. Water will undergo oxidation or loss of electron. So whenever anodic reaction of water, this will be the product, and these are the SRP value, that is 1.23 volt, and at cathode reduction of water occurs, and these are the SRP value of water at cathode. So this value you should mug it up, you should remember, it's compulsory because it will help you. Clear? Okay. So I hope these are the certain key point you will remember. Then I will start the reaction now. Okay. So we will see the various product obtained at the electrode during the electrolysis of aqueous solution of certain salts or certain electrolytes. Okay. So remember this: anode oxidation, loss of electron, gas is liberated at anode except hydrogen. Hydrogen will be liberated at cathode. Okay. So at cathode reduction occur, gain of electron, and metal is deposited. If is there any metal like NaCl, see in NaCl Na is metal, like PbCl2 Pb is the metal, Na2SO4 Na is the metal. Okay, then you can take KCl, mean K is the metal. So this all metal, CuSO4 Cu is the metal. So this all are the metal will deposit at what? At cathode. Then another key point, you remember that anodic reaction and cathodic reaction of water, this will again come in the fuel cell. I will explain detail in this chapter only, but for just now, for remembering, for mugging up, you remember that anodic reaction of water, during the anodic reaction of water, 4 electrons are lost, oxygen is obtained as a product, and H plus is a byproduct. Okay, that is H plus is also product. At cathode, reduction of water occurs, it will gain 2 electrons, hydrogen is obtained and OH minus is obtained. And SRP value is 1.23 and SRP value of that is of cathodic reaction is minus 0.83 volts. So this point you should remember. Please mug it up. Please make a post to the video, study it, then we will start to the further topic. Okay, I hope you have written it. Okay, I will start the further topic. So see you now. Okay, clear? Now one more, write down one more key point, third key point, write down this key point. Key point says less value SRP, lesser the value SRP act as anode, anode oxidation, oxidation loss of electron, gas liberation except hydrogen. This also please remember. Okay, the lesser value SRP, anode. If I have two electrode, I have electrode A and I have electrode B. This I also explained in the future previous classes. Anode A, if a value of SRP is minus 0.3 volt and B is minus 0.2 volt, so which is less? This is less, means this will be anode, then this will be cathode. Clear? So please remember this key point also. Less value SRP, lesser value of SRP, SRP not SOP. I will do each and every problem with SRP only. In certain books they have written SOP, but convert into SRP and solve the problem. And you know the relation, SOP and SRP are having the equal value but opposite in sign. Okay, so see, lesser the value SRP act as anode, anode oxidation occur, loss of electron, gas liberation except hydrogen. More value SRP, more value SRP, what man? Tell me. Cathode, reduction, gain of electron, all opposite values. Okay. Metal deposition occur. Metal deposition. Metal deposition. Okay. And hydrogen liberation. Okay. So lesser the value SRP, anode. At anode, oxidation occur. Oxidation, loss of electron, gas liberation. More value SRP, cathode, cathode, reduction occur, reduction, gain of electron and metal deposition. Please remember this, write down, then we will start the problem. Okay, now see here. First, in this first topic I am taking aqueous solution of NaBr. Okay. Please understand this, it's very important. Please be focused, don't write down just now. First see here, see the logic. Once if you understood, any problem you can solve. See here this. Aqueous solution of NaBr. Now see here what I have. I have NaBr and plus I have water also. Okay. So NaBr means Na plus and Br minus, and plus I have water also. Clear? Now see here, what will happen? We will see. So first we will see at anode. At anode, who will go? Sorry, first we will see portion of cathode. Please be focused here, it's very important. At cathode. So at cathode who will come? Na plus? Yes or no? Now there are also chances that water can also come, because here water is also present. This water can come at cathode also, and can also come as anode. Now we will decide who will come and who will not come. So when at cathode Na plus can come, similarly at cathode water will also come. Yes or no? When at cathode Na plus can come, so similarly at cathode water can also come, because in the previous problem I was having only fused. There was no portion of water, but here water is also there. So do not split the water. Understand, water can come as cathode also and water can come as anode also. So we will see both. Who will win? There are race now. There will be a race. Race between who? Race between Na plus and H2O at cathode. Similarly, race will be there between Br minus and water. We will see who will win. Okay. So see, at cathode reduction occurs. Na plus plus electron gives what? Na solid. Okay, similar at cathode, here also electron occurs. Yes or no? And here what will occur? Hydrogen will be obtained plus OH minus. Clear? Now here I will balance the reaction, that is 2 here and that is 2 and 2. Now we have to decide with the SRP values. We have to decide with the SRP value. If you write down the SRP value of Na plus, SRP value of SRP value of Na plus, please remember that is minus 2.71 volt. And what are the SRP value of water? So SRP value of water is minus 0.83 volt. Yes or no? So these are the SRP value of water and Na plus at cathode. Clear? Now you know, lesser value anode, more value cathode. Means if you have to stay at cathode, you should have SRP value more. So whose SRP value is more here? See, this is minus 2.71 and here it is minus 0.83. So whose value is more? This value, this value, this value is more. Yes or no? This value is less, because minus 1 is greater than minus 2. So here water reduction will occur and this reduction will not occur. Sodium reduction will not occur. Clear this part? See what I have done? I have taken cathode, Na plus, and water will also come. I have written both the reduction value, both the reduction reaction I have written. I have written the SRP value also. Now SRP value for sodium is minus 2.71 volt and SRP for water is minus 0.83 volt. Before that I have given one shortcut. Lesser value anode, more value cathode. Means to win the race in cathode you should have a more value. To win the race in anode you should have a less value of what? SRP. Now cathode means more value. So here two values are there. I have SRP for sodium is minus 2.71 and SRP for water is minus 0.83. So who will win? This value is more. Yes or no? So this value is more, means the reduction of water will occur, sodium will not occur. Okay. So at cathode I will obtain hydrogen gas. Clear this part now? Now we will see at anode. So this reaction will not occur. This reaction will not occur. Please remember this. Okay, now at anode. At anode, we will see at anode. At anode who will come? Br minus. Similarly, water can also come. Yes or no? And at anode what occurs? At anode oxidation occurs. So oxidation means here loss of electron and here it will be formed Br2. Clear? Similarly, water oxidation reaction means here electron, here O2, here H plus, balance the reaction. Okay, write down the SRP value for Br minus, and SRP value for Br minus is 1.08 volt. And here SRP value for water, please remember that is SRP value for water at anode is 1.23 volt. Okay. So SRP value here is 1.08 volt, here 1.23 volt. Now you know one who is less, anode. So whose value is less? You can see whose value is less, this value is less, 1.08. So here see lesser value of SRP, anode. So at anode who will win the race? Whose SRP value is less? Now see here, whose value is less? Br minus value is less as compared to water. So this reaction will not occur here. Which reaction will occur? This reaction will occur. Okay, so this reaction will occur at anode and this reaction will occur at cathode. Now combine the reaction. So here how many electrons are there? 2. So here 2, here also 2. So 2 electron get cut. So answer will be 2H2O plus 2Br minus. Clear? What will obtain? Will obtain H2 plus 2OH minus, H2 plus 2OH minus, and here we will obtain Br2. Clear? So what actually product we obtain? Now see here. At anode, see here now, this portion, H plus and OH minus. Now see here. At anode, what we obtain? At anode, we obtain Br2. So this Br minus has been cancelled out. Yes or no? This Br minus has been cancelled because this Br minus is completely converted into what? Br2. Okay. Now this at cathode, what occurs? Hydrogen gas. Yes or no? At cathode, so this H plus is also gone. So hydrogen gas. Now in the reaction is remaining what? OH minus. So here this OH minus and here this is Na plus is also remaining in the reaction. Are you understanding or not? I am feeling that you are feeling bit confusion. See here. These are the anodic and cathodic reaction occurs. See here, see Na plus cathode reaction will not occur. Means Na plus will remain as it is. So it was here NaBr plus water. So now see here Na plus Br minus and final product is what? OH minus also. Yes or no? So I will split here again H plus and OH minus. Now this Na plus reaction has not occurred. I hope you understood why it is not occurred. So Na plus remains as it is. Okay. Think about Br minus. See, Br minus reaction has occurred. Br minus is counted into what? Br2. So this reaction, this Br minus has gone to form what? Br2. Clear? Now come here. Here water H2O is converted into what? Hydrogen H2. So this H plus will convert into what? H2. So this H plus also gone to form what? H2. Okay. Now remaining is what? Remaining is OH minus. So here remaining is OH minus here and here remaining is what? Na plus. These two will combine and form what? NaOH. So after the electrolysis NaOH is remained, no? Here OH minus is there and Na plus is remained here itself. So after the electrolysis has occurred, product at anode. At anode, which product is obtained? At anode, product obtained is Br2. At cathode, which product is obtained? At cathode, obtained is hydrogen gas. Yes or no? At cathode, hydrogen gas is obtained and remaining is what? OH minus and also remaining is what? Na plus. Yes or no? Here Na plus is remaining because this reaction has not occurred. So the Na plus is remaining and in the final product we got OH minus. These two will combine and I will obtain what? Byproduct as NaOH. If I obtain the byproduct as NaOH, their pH will be less than 7 or greater than 7? Will be greater than 7 because it is a basic substance. So one question can come and the question is, after the electrolysis of aqueous solution of NaBr, what are the product obtained at anode and cathode and what will be the pH of final solution? So at anode bromine gas will be obtained, at cathode hydrogen gas will be obtained and after the completion of a reaction we observe that NaOH is remaining because here Na plus and OH minus. So NaOH is a one type of a what? Base. So it is a base means its pH will be greater than 7. So the basic substance will be remaining and byproduct will obtain as a what? NaOH, and this is also one method or you can call this a method to obtain a NaOH. Understood this portion? Clear? Just to remember the SRP, do a race between SRPs. At cathode who will win? More value of SRP. At anode who will win? Less value of SRP. Check it out. See what things are cancelling, they are converting into what and what is remaining. Combine that portion and start to solve the problem. Clear this part? One more question we will do and that question is, aqueous solution of CuSO4. You have to remember this SRP value. Please remember this SRP value. Now see here. In this portion, second question comes electrolysis. Electrolysis of aqueous CuSO4. Again here I have CuSO4 and I have water. Okay, I have to race between Cu plus 2, SO4 2 minus, because I will split here, and also I have here water. Then we will see who will win, who will how much product will be obtaining. Now see at cathode. First we will see at cathode. At cathode what I have? I have Cu plus 2. So reduction will occur, because yes or no? At cathode who will go? At cathode means reduction. Reduction occurs means Cu plus 2. Okay. So 2 electron will gives what? Cu solid. Also water can also come at cathode. Yes or no? And water at cathode means they will gain the electron and they will form what? They will form H2 and they will form OH minus. There are 2 here and here 2. If you write down the SRP value for copper, the copper SRP value is, you can write down 0.34 volt. 0.34 volt. And SRP value for water at cathode is minus 0.83 volt. One thing more I forgot to tell, electrolysis of aqueous solution using platinum electrode. Okay. So what is this new? Nothing this new, man. Platinum electrodes are one type of inert electrode. They will just provide a space to do what? Oxidation reduction. No role in the reaction. In further classes will come. Okay. But here remember, using platinum electrode, and platinum electrode is a inert electrode. So inert electrode does not have any kind of a effect. They will just provide a space to do oxidation and reduction reaction. Okay. So answer remains same here. So at cathode, Cu plus 2 electron, Cu solid, their SRP value is 0.34 volt. Okay. Their SRP value is how much? 0.34 volt. And H2O reduction reaction, their SRP value is minus 0.83 volt. Now lesser the value means anode and more the value means cathode. So who will win the race here? This is the more value means he will win the race and he will not come. So this reaction will not occur at cathode. Which reaction will occur at cathode? Cu plus 2 reaction will occur at cathode. Now we will come at anode. At anode what I have? At anode I have SO4 2 minus and also I have water. Now see here, very important topic here, very important point. Anode, at anode oxidation occurs. Yes or no? At anode what occurs? At anode oxidation occurs. Okay, oxidation means what? Loss of electron. Now if you come to the SO4 2 minus, if you see this S, so S plus 4 into O equal to minus 2. Redox reaction, 4 into minus 2 equal to minus 2, S minus 8 equal to minus 2, S equal to 6. So SO4 2 minus, sulfur is in a plus 6 state. Yes or no? This is the maximum oxidation state of sulfur. Plus 6 is the maximum oxidation state of sulfur, means sulfur can lost maximum 6 electron. Further it cannot. Now at anode what you have to do? You have to compulsory lost the electron. Electron must be go. Yes or no? Electron must go. But here the maximum oxidation state is reached. How I can lost the electron? First of all, SO4 2 minus, in that S he is sitting by losing 6 electron. All the electron he has lost. Now further electron sulfur cannot lost from SO4 2 minus. So remember at anode this oxidation does not occur only. Are you getting my point? See, in SO4 2 minus, sulfur is plus 6 oxidation state. This is the maximum electron it can lost. And in SO4 2 minus, sulfur is having plus 6 state, means it has lost all the electrons and he is sitting in SO4 2 minus. Now at anode we are asking SO4 2 minus to lose further electron, but sulfate now SO4 2 minus, now it cannot lose the electron. Their maximum oxidation state is plus 6. Now it cannot go beyond that. It cannot lose the electron, means oxidation of SO4 2 minus does not occur. Oxidation of SO4 2 minus does not occur. Oxidation of SO4 2 minus does not occur because of plus 6 oxidation state, which is its maximum. So whose oxidation will occur? Water. So water will undergo here oxidation. It will lost electron. It will form here O2. It will form here H plus. So here 2, 4 and 4 electron. Need not to write down the SRP value because we know this reaction will not occur only. Clear? Now, we'll compare this. SRP need not to write. I hope you understood now why I am writing here SRP, because sulfate oxidation will not occur. I hope you understood now. So, we'll write down how many are there? 4. So, we'll multiply here 2. So, 2 2s are 4, here 2. So, this 4 electron get cut. Answer will be 2 Cu plus 2 plus 2 H2O gives what? 2 Cu solid plus 4 H plus and plus O2. So, we will see the product. Please write down this first. Chalo. Written? Okay. Now see. We write down the product and we will see what are the products obtained at anode and cathode. So, see here at anode. What product we obtain at anode? At anode, this is anode, okay. At anode, we obtain what? At anode, we obtain oxygen gas. So, oxygen gas will liberate at anode. At cathode, what will obtain? At cathode, we will obtain Cu. So, see, these are the product obtained at anode and cathode. Now, remaining is what? Now, see here. This Cu plus 2 has gone to form what? Cu. Okay. Now, see here H plus and OH minus, if I do here, this OH minus has gone, suppose this, because here O2 is liberated, no? So, this OH minus has gone to form what? O2. Now, remaining is what here? See here, H plus is remaining as the product. And one thing more is remaining in the product, that is SO42 minus, because SO42 minus oxidation does not occur. It will remain as it is in the solution. So, SO42 minus was as it is in the solution. After doing the electrolysis, I got a product what? H plus. So, these two will combine, yes or no? And will form what? H2SO4. This is what? Acid. Acid means what? pH will be less than 7. So, the question comes, what are the product obtained at anode and cathode during the electrolysis of a copper sulfate using platinum electrode? At anode, oxygen occurs, oxygen is liberated. At cathode, copper is deposited, and after the electrolysis, the solution becomes acidic. Why? Because there will be a formation of H2SO4. How it is forming? At the final, after the electrolysis, H plus is formed during the reaction, and SO42 minus oxidation does not occur, means it will remain as it is in the solution. So, this H plus and this SO42 minus will combine together, forms what? H2SO4, and H2SO4 is a what? Acid. So, their final solution pH will be less than 7. So, this type of also one question is asked, what will be the pH of the solution, final solution after the electrolysis? If the electrolysis of aqueous solution of CuSO4 using platinum electrode occurs, pH will be less than 7. There is a 4 mark MCQ, somewhere it has been asked. Please remember, the question was, what is the pH of the solution, of the final solution during the electrolysis of aqueous CuSO4 using platinum electrode? So, the pH is less than 7 because the final solution is an acidic. That is why H2SO4 is an acidic substance. So, the final acidic solution means pH is less than 7. I hope you have remembered. And I hope you have understood. If you have any doubt, please be free to ask me, comment me. I don't want your positive comment. I want your comment related to your doubts. Please ask me doubts. If you have any topic, if you are not understanding any topic, I will reply you within 24 hours. Try to do this, try to understand this. Still one more topic is there related to this only. I will do in the next class. Thank you.